Here's 8.3. We'll call it day 2, again, even though the schedule says just 8.3. It's time to kind of just build our way towards doing a 4-step problem. Got 2 of them in here because there's kind of 2 different routes the 4 steps with means can go. Both will involve T procedures. Because in the first day we took a good look at the T procedure itself, why we use it, and then kind of how we go about getting getting critical values. Because we can't use those Z critical values from section 2. This we don't need. Just a little reminder here that random condition is the same. Normal is a little bit different. Okay, with means, remember we hit that magic number of 30. This is just a bunch of summary of stuff. Except here, I don't know if we stopped to address it specifically. There was a slide in here once upon a time. It's possible we didn't get to it yet that talks about how T procedures are in what's called robust in stats. And it means they still work okay if a condition is violated. And T procedures are robust against the normal condition. Okay, we can't just disregard it altogether, but we can be a little iffy. So if n is less than 30, it's not a deal breaker. You would just make a box plot on your calculator, and you would check for skews or outliers. You don't need to do that if n is 30. Then the normal condition is automatically met. All right, so for this particular example, we're going to construct an interval. Obviously, go to the tutorials if you need to see more on the calculator stuff to use it to construct a t-interval. This one, under a one-sample t-interval, you would put it in data mode. Okay, you put it in data mode because all we have is the data. So those 18 pieces of data would have to go into list 1. Okay, and then when you go to construct the interval, you'd be in data mode and you'll get all the numbers that you need. Okay. State step, remember we need 2 things. Parameter and confidence level. This one's really straightforward because it's, that stuff is basically right above it. That typically won't be the case. It's the parameter and the confidence level is usually kind of hidden in the context of the problem. But we want to construct a 99% confidence interval. For mu, mu is the true mean. I gotta abbreviate here a little bit because I'm short on space. The true mean number of pieces used to absorb 1/4 cup of water. That's a fairly wordy parameter. You'll see that the state step and its length kind of depends on that because the confidence interval doesn't. You just, But the true mean number of pieces of toilet paper used to absorb 1/4 cup of water. And it's some parameters just aren't that wordy to say. This one is. Whoops. Alright, so first thing in plan, name the procedures. We are going to do a one sample T interval. For random, we have an SRS of n equals 18 rolls. Normal, n equals 18, which is less than 30. Which means we must check for skews and outliers. You should make a box plot. You could do a histogram too, but the box plot is the easiest. And you should use the calculator, and at this point the data is already in list 1, so all you basically have to do is go to your stat plot up in the top left of your calculator and make sure it's set to a box plot, and then just hit zoom 9 and it's going to appear right on your screen, and we just copy it down. And on this one, all I would check for, because we're just checking shape, okay, the center is pretty much right in the middle, and then it had a left tail that's a little bit longer than the right. That's all you need to do, okay? When I'm looking those over, the box plot will probably have some characteristic that doesn't make it perfectly symmetrical, and that's all I'm really checking for, okay? And so at this point I would just follow up and say, I'm looking at that box plot, there doesn't appear to be any skews or outliers. Okay. All right, now down in the do step, this is where we would go to our calculator. And when we run the test, it'll give us all this information. 24.94 is X bar. It'll have that. Plus or minus 2.898, okay, that will come from the table, right? Because I'm also going to specify over here that on this interval I used 17 degrees of freedom. S, 2.86, that's the standard deviation of our sample over the square root of 18. Okay, the test feature will also give you the interval, which you should just copy down with it. And there you go. We're 99% confident that the interval of 22.99 to 26.89 captures the true mean number of squares of generic toilet paper needed to absorb 1/4 a cup of water. Okay? So that's a really good one to study off of, because of any element in a t-interval for a mean that I could throw at you, that one basically does. Right? It's in data mode, so you would have to go put the data in list 1. You have to make the box plot. It's got a pretty wordy parameter. Yeah, it's got a lot going on there. Okay? Again, a good one in the sense that test-wise, I couldn't really throw much at you that that one doesn't have. Let's contrast that with this one. Okay? Now right off the bat, what I want you to see on this one is under the calculator feature, you would have to switch over and use what's called stats mode, because this problem has a really different feel to it. We didn't just get the data, right? That would be ridiculous if we did, because the sample size is 250 from this particular school. and we're estimating the number of hours of homework that students are doing a week. Okay, it doesn't just give us the data that was collected for all 250, it just summarizes and gives us the two measurements from that data that we would want, the mean and the standard deviation. Okay, in your calculator, if you switched over to stats mode, that's what it's going to do. It's just going to ask you for x bar and s, which we have at 10.2 and 4.2. Okay, so under state, a 95% confidence interval for mu where mu is the true mean number of hours students study at this school. Okay. Same two things as always, confidence level, and then a definition of the parameter. Same as before, we will do a one sample t interval. First condition to address is random. SRS of n equals 250 students. Normal, very different story from the one before, right? As we stated, n is 250, which is greater than 30, which means with a mean, the normal condition is automatically met. Okay, you'll see in these problems, typically these two things go together. If you have a sample of 30, you're good to go to stats mode, and you're going to like those because you don't have to enter the data in, you don't have to do the box plot. Normal condition is much shorter and easier. All right, now under the do step, same deal. Then we'll have the interval. But something that's kind of interesting here. Okay, I'm going to go with the calculator. Okay, that's the interval I would get from the calculator of 9.67 to 10.73. 10.73. If I went off the calculator, it would use 249 degrees of freedom. Okay, this gets a little interesting because in the table, there's no 249. It starts to skip over. At that point, I can't remember. It goes like 100 and maybe to 200 to something, 500, and then up to 1,000. Okay, because the critical values at that point aren't changing all that much. But if I use the calculator for my work, I have to write out work that's consistent with the interval that I made. Okay, so for my work, I will put T star, and then of course my standard error of 4.2 over the square root of 250. Okay, if that shows up in your do step, you need to have the degrees of freedom in the do step as well. That tells me is I can check those two, and it's basically an indicator that you're saying I used the calculator to get an interval. Here's the degrees of freedom the calculator used. As far as what the critical value is, I can't get it, right? My only means to get the actual value is the table, and I can't. So you just leave it as t, okay? Now we're 95% confident this interval captures the true mean hours spent doing homework in the last week for students at the school. This is what I had alluded to earlier. This is more of just a FYI type of thing, but that's what's going on with that normal condition with the whole box plot thing. Is T procedures are robust against that normal condition, so we can push the issue. Right? It's typically 30 to use a normal curve with means, and we still go off of that. But if we're under it, we'll kind of check and see if we can get away with it. Here's 3 of them to think through. Would you use a normal curve in this setting? This is kind of a no-brainer. Sample size is 30, or 50, which is bigger than 30, right? We've known that for a while, that we'd feel great doing a t interval with that data. Here I would say no. N equals 5. And this point up here, I'm not going to go through and verify it, but just from observing it, I feel confident saying there's an outlier. Okay, so that data right there, and remember, in 4-step problems, the conditions are always met, so that's not going to be data that you're going to see. Okay, not in a 4-step anyway. Okay, this one's a little more intriguing. Okay, this, maybe you could see something like this in a 4-step where it's like, hey, maybe we have a little bit of a skew. Okay, for us to get concerned about a skew, it's got to be major. All right, so if you were asked about this, are you going to call that a major skew or not? You could go either way. Okay, if this were in a 4-step, you always go off of the conditions being met, so you don't stop and not do the do a conclude. So I'd say, all right, n is 20. I'm gonna, and there appears to be a right skew. Okay, if you really do have concerns, because here's the other deal: if it was like a data problem in a 4-step, maybe, where you made the box plot yourself, it's possible you made the box plot incorrectly. Okay, so obviously don't stop. Here's kind of the magic words if you really have concerns on this step. We say that we'll proceed with caution. Our normal condition was iffy, we're pushing it. If that normal condition really isn't met, obviously our interval is not going to be great, right? So that's just saying that we're going to go ahead and do it, but we maybe have some reservations about the normal condition.